All right, so let's start chapter 1. And section 1.1 is on inductive reasoning. So making conjectures or inductive reasoning. So the summary pieces that are at the beginning of your notes here say to keep in mind that a conjecture is an unproven conclusion based on evidence. So that's a definition you do need to understand what a conjecture is, okay? And an unproven conclusion based on evidence. So what that's kind of saying is something that you're like, well, okay, this is what I think it is based on what I can see. I went online to define conjecture, and what it said online is that it's an opinion or conclusion formed on the basis of incomplete information. So I think this incomplete information part is saying, well, it's only what you can see. It's not necessarily the whole picture, but um, you're coming up with something based on evidence, on what you see. Okay. Inductive reasoning, there's another definition. Inductive reasoning involves making a general conjecture based on specific cases by looking at patterns and recognizing properties. So if you see something happening over and over, you're going to induce that it's going to happen again. That's inductive reasoning. Okay, so when things start to make a pattern, like as a teacher, if I see that little Billy doesn't come every single Monday, I guess because he doesn't want to come in after the weekend, I'm going to start to assume that he's not going to come in on Monday. Might not be the case, but that's what inductive reasoning is. And additional evidence may support a conjecture, but it does not prove it. So a conjecture is a conclusion based on evidence. So if you could go to the first example in your notes, it says draw a pair of intersecting lines. So I went ahead and did that. And it says measure and record the opposite angles as shown. What conjecture can you make? So we have already talked about opposite angles actually because we've already done chapters 2. But you know that, let's move to the pen here. You know that opposite angles are equal, but let's see what happens if we made a conjecture. So we know that opposite angles are here and here, okay? So we drew intersecting lines, measure and record the angles as shown. So if I use this protractor here and I measure the angles that I marked, if you were using a protractor, you would slide that bottom line across the line, okay? And then I'm going to read this angle here. So my pen, I'm going to read right here, okay? So 10, 20, 30, maybe looks like about 36 degrees, about, okay? 35's right there, it's a titch over. Okay, so that angle's 36. If I took my protractor and measured this other one, so I'm going to slide the center to where they intersect with my line. There we go. I'm reading from the center. Again, I'm going to read. Come on, pen, work with me here. Okay, 35, 36 degrees based on the protractor. Okay, so I measured the angles. They were both approximately 36 degrees. And then it says, what conjecture can you make? So my conjecture could be when two lines intersect, what? What did we conclude? Opposite angles will be equal. You're like, yeah, I already know that. I did a bunch chapter a few before, but that's the conjecture. So when two lines intersect, opposite angles could be equal. Okay? So easy peasy. You just look at the evidence you see, and based on the evidence, come to a conclusion. That's what a conjecture is. Okay? If I wanted to support it, I could measure these two angles. Okay? I could start over, and I could see if this opposite angle equaled this angle. I could start all over and do that as well to support my conjecture. Okay, example number 2. It says examine the pattern in the addends and their sums. What conjecture can you make? Okay, so addends means the parts that are being added, and then their sum, of course, is the answer. So what conjecture can you make? So look what's happening. 1 plus 3 is 4. 3 plus 5 is 8. 5 plus 7 is 12. 7 plus 9 is 16. So did you notice a pattern for the addends? Okay, the things being added. I noticed that they are consecutive, meaning in a row, consecutive odd numbers. Okay, 1 plus 3, 3 plus 5, 5 plus 7, 7 plus 9. So they're odd numbers that are in a row. They're consecutive. Okay, what about their sums? What do you notice here? 4, 8, 12, 16. Well, their sums are even. I've noticed that. I also noted 4, 8, 12, 16. They are multiples of 4. Okay, they all are divisible by 4. So my conjecture could be what? When you add consecutive odd numbers, the sum will be a multiple of 4. This pen is not writing very well. Multiple of 4 means that it's divisible by 4. Okay? So, is there an example that would support my conjecture? Let's come up with a few random consecutive odd numbers. What if I added, come on pen, here, let's scroll down a little bit. What if I added 101 and 103? Okay, 101 and 103 are consecutive odd numbers. They add to 204, which is divisible by 4. So that one works. What if I added, let's say, 35 and 37, consecutive odd numbers? They add to 72, which is also divisible by 4. So I came up with two examples that support my conjecture. So that's the end of section 1.1. Have fun with your homework. Some of you will absolutely love this chapter. Some of you will hate it. But give the questions a try and come and ask help when you need.